The digital apocalypse is officially scheduled for exactly 3:14 and 7 seconds AM on Tuesday, January 19, 2038. You might want to mark your calendars, assuming your calendar app survives. You see, humans tell time using a needlessly complicated system of days, months of varying lengths, leap years, and daylight saving time, which exists purely to ruin your sleep schedule twice a year. Computers, however, are essentially just incredibly fast toddlers. They don't want to do complex math to figure out what day it is. They just want to count things. Specifically, they want to count seconds. Back in the early days of computing, the nerds in charge decided that time officially began on January 1, 1970. This is known as the Unix epoch. As far as most computers are concerned, nothing existed before this date. Dinosaurs? A myth. The moon landing? Irrelevant. The invention of the toaster? Never happened. There is only the time since January 1, 1970, and the computer just counts up from there. 1, 2, 3, and so on. But computers don't have infinite space to count. They store this number of seconds in what's called a 32-bit integer. If you imagine a bit as a tiny light switch that can only be on or off, a 32-bit integer gives the computer 32 of these switches to represent a number. Using 32 binary switches, the highest number you can possibly count to is 2,147,483,647. Which sounds like a very big number. It is, for example, exactly how many times I've thought about eating a bagel today. But when you are counting seconds, 2 billion seconds is actually only about 68 years. So, if you start counting on January 1, 1970, and you wait 2,147,483,647 seconds, you eventually hit a wall. That wall is January 19, 2038. At exactly 3:14 and 7 seconds Universal Time Coordinated, the computer's counter will run out of room. It will try to tick over to the next second, but because it doesn't have a 33rd switch to flip, it completely panics. In a computer process called integer overflow, the number wraps all the way around to the lowest possible negative number it can store. In the blink of an eye, the computer will suddenly think the year is December 13, 1901. Now, before we talk about how this digital time travel will cause planes to miscalculate routes, bank databases to collapse, and your smart fridge to freeze your lettuce, I need 5 seconds to ask you to please subscribe to this almost dead YouTube channel before the algorithm buries it in 1901 forever. Okay, thank you. The last time we had a time panic, it was the Y2K bug. People thought the world was ending because computers only used 2 digits for the year, turning 2000 into 1900. Billions of dollars were spent fixing it, and mostly, it worked. The year 2038 problem, or Y2K38, is basically the sequel to Y2K, and just like most sequels, the stakes are technically higher but everyone is paying way less attention to it. The obvious solution is to just give computers more room to count. Instead of using 32 switches, we can just upgrade them to use 64 switches. This is known as a 64-bit integer. Moving from 32-bit to 64-bit sounds like we are just doubling the capacity, right? Like maybe we buy ourselves another 68 years and have to do this all over again in the 22nd century. But that's not how binary works. Every time you add a single bit, you double the maximum number. So a 33-bit number is twice as big as a 32-bit number. By the time you get all the way up to 64 bits, the maximum number you can store isn't double 2 billion. It is 9 quintillion, 223 quadrillion, 372 trillion, 36 billion, 854 million, 775,807. If a computer is counting seconds using a 64-bit integer, it won't run out of time in 68 years. It will run out of time in approximately 292 billion years. To put that in perspective, our sun will explode and swallow the Earth in about 5 billion years. The entire universe as we know it might succumb to heat death long before that 64-bit clock runs out. So, as far as humanity is concerned, a 64-bit clock is basically infinite. Problem solved forever. We did it. Except, not quite. This is where the interesting twist comes in. Updating your laptop or your smartphone to a 64-bit operating system is easy. In fact, most of you watching this are already using 64-bit devices, so your phone isn't going to turn into a brick in 2038. The real danger isn't the computers on your desk, it's the computers hidden everywhere else. We live in a world built on embedded systems. These are the tiny, invisible computers running the anti-lock brakes in your car, the GPS satellites in orbit, the water treatment plants, the pacemaker in your chest, and the traffic lights in your city. Millions of these devices were built 20 years ago, running on extremely basic, incredibly stable 32-bit software that was designed to literally never be updated. Because why would you update a traffic light? It just turns red and green. These systems don't have a software update button. To fix them, an actual human being has to physically go to the device, open it up, and replace the chips. And nobody knows where all of these devices are. Many of the companies that built them went out of business a decade ago. It's a digital scavenger hunt where the prize is not having your city's power grid suddenly think it's the peak of the Edwardian era. So, as 2038 approaches, we aren't going to see a single massive apocalyptic event. What we are going to see is a slow, annoying wave of weirdness. An old ATM might refuse to dispense cash because it thinks your debit card expires in -36 years. A database for a local government might suddenly delete a bunch of records. A perfectly good piece of medical equipment might just shut down and refuse to boot. We have successfully engineered a permanent solution that will outlast the burning of our sun, but we are still going to have to spend the next decade frantically crawling through the metaphorical basement of the internet to replace the old plumbing. And frankly, I don't think any of us are ready to bring back wearing top hats and dying of dysentery just because a computer ran out of light switches.